Let us continue our discussion on logical implications and equivalence. If you look at a proposition P, with that, if you perform logical and with the truth value true, this implies that we get P. The reason is this: if this is true, then it implies true. If this is false, it implies false. Which means what? The truth value actually depends on the value of P, which is why we conclude P and T implies P. Let's look at this. So it is P or T, then we can always conclude that it is true. Whether it takes the value true or false, then we get this. Correct? Similarly, you look at P and F, and whether it is true or false, this is going to be false always. P or false. If this is false, then it is false. If this is true, then it is true. Then it depends on P. Fine. So now you can ask. So you have a proposition P. Can I imply this P or say Q? You have a proposition P. Now I am saying, will this imply P or Q? Q is some other proposition. So in some sense, you are adding a proposition along with P. Now the question is, does this imply P or Q? We can check this. So let's look at possible values for PQ. Possible values are this. Now let's look at P or Q. It is true and it is R. So even if one is true, it is true. Now we we want to know whether this X implies Y. P implies P or Q is a tautology or not. If it is a tautology, then P implies P or Q. So true, 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 false, true, and then false, false. And so if you look at the implication, it is true, which means this one is a tautology. Therefore, in a context, if P appears, you can replace P with P or Q. Okay? Let's look at this. Can I simplify? Meaning in a context P and Q appears, can I conclude P? From this, let's look at P and Q. So we want to know P and Q. Does P and Q imply P? So P and Q implies P. It's true, true, false, true, false, 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 false. So therefore, it is true everywhere. So which means this is a tautology. Therefore, this implication is true. This implication is true. Fine. So there are many interesting implications which you can refer my scribe or standard text, and we will discuss some of them as part of problem session or tutorial session. Consider this. given a statement, say P implies Q, there are related expressions or related statements. One is called inverse of P implies Q. What is inverse? Inverse is negation P implies negation Q. This is one. There is something called converse of P implies Q. Converse of P implies Q is Q implies P. Then there is something called contrapositive which is so given an expression or a statement P implies Q, inverse is negation P implies negation Q, converse is Q implies P, contrapositive is negation Q implies negation P. Now the question is, given this, are these things equivalent to this? Or if P implies Q is given, can I imply negation P implies negation Q? Or if P implies Q is given, can we imply the converse Q implies P? Or if P implies Q is given, can we imply the contrapositive which is negation Q implies negation P? Does this imply inverse? Does this imply converse? Does this imply contrapositive? That's on one side. On the other side, are they equivalent? Meaning, so this inverse also, does this imply this? Converse imply this? Contrapositive imply this? Okay. Let's look at the first one. Look at possible values for PQ. Okay. And inverse is negation P is false, false, true, true. Negation Q is false, true, false, true. P implies Q is true, false, true, true. Negation P implies negation Q. Premise is false, premise is false. This one is false, this one is true. Now we want to know P implies Q. Does this imply this? So let's look at X implies Y. You see that it is true. This one is true. This one is false. So that shows that it is not a tautology. Since it is not a tautology, one cannot conclude that P implies Q implies negation P implies this. So given P implies Q, inverse does not follow from the statement. Okay. Reason, it is not tautology. Similarly, let's look at Q implies P. If you look at Q implies P, it is true, premise is false, and this one is false, this one is true. Now P implies Q is X, this one is Z. Is this true? P implies Q is true, this one is true, so true, premise is false, true, false, false, true. And here again we see that converse does not follow from the statement P implies Q. Fine. However, contrapositive follows. Just before this, we had discussed this identity, converse follows. In fact, we have proved that they are equivalent. So this also implies, which means P implies Q is equivalent to saying negation Q imply negation P. So given a statement P implies Q, you can replace that with its contrapositive. You cannot replace that with converse or inverse. Contrapositive alone logically follows from the statement P implies Q, whereas inverse and converse does not follow always. So reason we see that it is not a tautology. Since it is not a tautology, implication is not guaranteed, whereas for contrapositive it is guaranteed.